Hello everyone, welcome to the Somnia Developer Education Series, Somnia 101. Today we are going to be looking at how to deploy smart contracts on Somnia. And we are going to be taking a look at three different options. One, how to use RemixIDE, how to use Hardhat, and how to use Foundry. Let's jump right in. We're going to be looking at how to use RemixIDE in this first option, and what you can see on your screen is a simple smart contract. It's called the greeter contract. Greeter contract has a string variable declared called name, and it has two functions: change name, which is a write function, and greet, which is a read function. So the change name simply changes the name that was set in the constructor when the contract is first deployed, and then greet returns the name plus hello. To deploy this smart contract to the Somnia testnet, we are going to be using an injected provider. You can inject one of the wallet options that you have in your browser. In this example, I'm going to be leveraging on MetaMask. So first, we have to compile our smart contracts. I have my settings for my RemixIDE set to auto compile. So compiling the smart contracts helps generate an ABI and a bytecode, which is machine readable code that helps us to deploy our smart contracts on chain and then makes it available for us to read via the ABI methods. So after we have compiled the smart contract, we want to deploy and then run transactions. So like I did mention, we have to inject our wallet environment into our RemixIDE so that it gives permission for it to deploy smart contracts via our wallet, because you do have to pay to get your wallet deployed on chain. So we have a virtual environment that Remix generates for us to be able to deploy smart contracts in a test environment on Remix and interact with those contracts. But we are going to be injecting MetaMask into our RemixIDE, and then it's going to prompt me to sign into MetaMask. I'm just quickly going to enter my password into MetaMask, log in, and then it brings me into the MetaMask environment. It selects the network, which is 50312, and that is the Somnia testnet, and it ejects one of my accounts. So to deploy this smart contract, the constructor requires us passing an initial name. So I'm just going to set a name. I'm going to set a name. I'm just going to type in my name, and then I'll just click on deploy. This will deploy the smart contract, and it's going to return to us the approve function first for us to approve this via MetaMask. I'm going to click on confirm. So that transaction has been approved. So it's a write operation. That means it changes the state of blockchain. You can see that this was returned in a matter of seconds. So there's our transaction hash and then our smart contract address. So you can interact with this smart contract in your Remix environment. You can change the name, call greet, see the name that was deployed, which is Emmanuel, see the owner address, and call greet is going to say hello Emmanuel. So I can interact with the smart contracts. Say I want to change name from Emmanuel to Emma, so it's just going to say change name to Emma. Call that function. It's going to prompt me to approve this transaction. Click confirm, and then once the transaction finalizes, it changes the name. So if I call greet now, it's going to say hello Emma. So that is our first option on using Remix to deploy smart contracts to the Somnia testnet. And just to show you how this looks like on the Explorer, I'm just going to copy the contract just to demonstrate it on the Explorer. I'm just going to type in, go to the Shannon Explorer, paste the copied contract address, and then you're going to see, and then you see the smart contract. You can see that the smart contract was first created, and then I call the smart contract method to change name. So that is an example using RemixIDE to deploy smart contracts on Somnia testnet. In our next example, I'm going to walk us through how to use Hardhat to deploy smart contracts on Somnia. To begin, I'm going to create a directory where we would have our program running. I'm going to call this Somnia Hardhat example. And once this directory is created, once that folder is created, I want to change into it. The example is still Somnia Hardhat example. So now we are inside Somnia Hardhat example. To create a Hardhat application, we need to first of all initialize an npm, a folder where we can install packages, node package modules. And if we're going to add that folder that we just created, it's going to be on the desktop. Somnia Hardhat example, there it is. Add it to our list of folders, and from that npm command that we ran, you can see that it created a package.json file for us, which will enable us install npm packages that we can use to run our programs. So I'm going to open up a terminal where we'll be running all our commands from. To continue with our project, we want to start by installing Hardhat. So we'll run the npm install command where would pass a flag to add Hardhat. So the package.json directory, and then the package itself is called Hardhat. So we run the install command. We're going to wait for that to install. I'm going to forward this video through the installation process, and then I'll come back once the installation process is completed. Hardhat has been installed and it is now part of our packages in the dev dependencies. So the next thing that we are going to do is to initialize the Hardhat project by running the command npm hardhat init. And this is going to give us a couple of prompts regarding the program that we want to create. So for this particular example, I want to create a TypeScript project with the root not changing. It's going to be still Somnia Hardhat example, and of course I want to add a git ignore file, and of course I want to add the dependencies that are going to help me eventually deploy this application. It is installing the Hardhat toolbox, which has packages that you can use for testing your application and also for deploying your smart contract. We have Hardhat now initialized and set up, and going through our program directory, you can see the default smart contract that it came with. It's the log.so smart contract. We're going to replace the smart contract with the same example Gritter contract that we use when we deployed an example using the RemixIDE. So Hardhat has the ignition module where it has the file, that the scripts that you can run to deploy your smart contracts to a blockchain network. And to do that, we would have to add a configuration called networks into the Hardhat config, where we would pass the configuration for the Somnia network. But first, let's update our smart contract. So I have simply copied the smart contract for the greater.so, and then I have pasted it in here. So I'm not going to rename the smart contract file. So now is the same smart contract that is pasted in here, as you can see. I'm going to save this file, and then I'm going to go into I'm going to save that file. Now that file has been saved and we have the contract greater. We are going to compile our smart contract using Hardhat, and Hardhat will compile the smart contract into machine readable bytecode and also generate an ABI. And to do that, we would run the command npx hardhat compile. It successfully compiled one solidity file, and when it compiled it, it generated two new subfolders, the artifacts and the cache. So in the artifacts, when you open this, you can see the ABI file here in the greater.json. The ABI is used to pass arguments to build out UI for a smart contract using libraries such as VMJS or Web3.js or ATAS.js. So to deploy the smart contracts, we are going to make use of the modules in the ignition and then write a very simple script that would take our compiled smart contract, which is the greater contract, passing the initial argument, and then deploy to the smart contract and return all information about the smart contract, including the smart contract address. So I'm using the default names that are already available in the file, and then to do this, we would add network information to the hardhat.config file. We'll pass in network arguments and then passing the name for the particular network that I want to deploy to, in this instance Somnia, and then for that we'll pass in two parameters. The RPC will pass in two parameters. The RPC URL that we want to use will pass in two parameters. The RPC URL that we will pass in two parameters. One is the RPC URL that we want to use in this instance, the Somnia Dream RPC, and then also would pass in the private key for the accounts that we want to use to deploy our smart contract. So I'm going to move away from the screen and then paste my private key. Please note that your private keys are always meant to be kept, of course, private. The private key should be from an account that contains STT tokens that you'd use to pay for this transaction. So now that we have compiled our smart contracts and written our script to deploy our smart contract, we'd run the hardhat command to deploy the smart contract. And the hardhat command is hardhat ignition deploy, locate the directory where the deploy script is, and then we'll change our network from localhost to Somnia. So this command will deploy our smart contract to the Somnia network. So we'll confirm that I want to deploy to the particular chain ID 50312, which is Shannon testnet. So we'll enter the command to deploy our smart contract, and then confirm that we want to deploy to Somnia. So it's going to be deploying greater, and there you have it. Our smart contract is successfully deployed to this address. For a quick recap in this example, we first of all write our smart contract, compile the smart contract so that it generates the bytecode and then the ABI. We update the script for deploying the smart contract, and then we update the hardhat.config file where we pass the network information and the RPC URL and also the private key to the account I want to use to deploy the smart contract, and the account must contain STT tokens. And then we run the command to deploy our smart contract, which will then deploy our smart contract to the Somnia network. So in our last example, we are going to be deploying it using Foundry. First, we have to initialize our Foundry project by running a forge init command. We will call this example Somnia Foundry. Now that project has been created, we can simply change directory into it, Somnia Foundry. This is our Foundry file, and then you can find the example smart contract in the counter.so file. This is the example smart contract in the default Foundry build, and we're just going to go ahead and continue with the smart contract. First, we compile our smart contract by running the command forge build. This compiles the smart contract into machine readable bytecode and also generates the ABI. To deploy the smart contract to the Somnia network, we use the forge create command, where we pass in the ROPC network, the private key, and then the file name. It compiles the file and then returns smart contract address where it was deployed to. That is our final example on deploying smart contracts to the Somnia testnet using Remix, Hardhat, and Foundry. With that, we have come to the end of this session. Please remember to post your feedback and comments in the chat, and also do well to subscribe to this YouTube channel. See you in the next one. Bye for now.